In this section, we will take a quick look at two other types of titration, which are precipitation and compleximetric titrations. First, let's take a look at precipitation titrations. This type of titration commonly involves the silver cation or Ag+, and therefore it's also called argentimetric titrations. In argentimetric titrations, silver nitrate is used to titrate anions that precipitate silver, for example, chloride, bromide, and cyanide ions. An example of a chemical equation would be for chloride ion, silver nitrate would react with the chloride ion to form the precipitate of silver chloride and nitrate ion. For argentimetric titrations, the indicator used is potassium chromate, which would produce a red color with excess Ag+ ion. Another method of doing titrations involving precipitation is as an indirect titration or back titration. This method is actually more common. For example, excess silver nitrate is added to the sample that contains either chloride or bromide ions. The amount of silver nitrate that did not react is determined through titration with ammonium thiocyanate. In this titration, ferric ammonium sulfate or ferric alum is used as an indicator to detect excess thiocyanate ions. The indicator would turn blood red in the presence of the thiocyanate ions. Precipitation titrations are used in the pharmacopoeia assay of sodium chloride and potassium chloride tablets, thiamine hydrochloride, mustine chloride, and carbamyl. Here's an example. For the assay of potassium chloride tablets, a quantity of the powder containing a certain amount of chloride ions is dissolved in water and diluted. This is then titrated with silver nitrate, and the indicator used is potassium chromate. So this is a direct titration. Next, let's take a look at compleximetric titrations, where complex ions are formed. This type of titration is most commonly used in the estimation of metal salts. EDTA, which stands for ethylene diamine tetraacetic acid, is the most common titrant used. EDTA forms stable 1:1 complexes with many metal ions, except for alkali metals such as sodium and potassium. The structure of the complex ion is shown on the lower right. You can see the metal ion in the center, and EDTA kind of wraps itself around the metal ion and forms coordinate bonds with that metal ion. This method of titration is fairly sensitive and it's able to detect metal ions at very low levels. The most common form of EDTA that we use is the sodium salt called disodium edetate. For compleximetric titrations, the indicator used would be a chemical dye that can bind to the metal, and it would change color when it is displaced by EDTA. The most common indicator used is modern black. Modern black forms a wine red complex when it is bound to metal ions. But when there is excess EDTA, the metal ions within modern black would bind to EDTA instead, and this causes the solution to change color to a dark blue color. Titration with EDTA is used in the pharmacopoeia assays of drugs that contain metal ions, such as bismuth subcarbonate, calcium acetate, calcium chloride, magnesium carbonate, magnesium hydroxide, zinc chloride, and zinc undecanoate. If the metal salt to be determined is insoluble in water, then a back titration or indirect titration can be done instead. For back titration, the sample would first be heated with excess EDTA to form a soluble EDTA complex of the metal. Then, the excess EDTA would be determined by titration with a solution containing magnesium 2+ ion or zinc 2+ ion of a known concentration. This method is used in the pharmacopoeia assay of aluminium hydroxide, aluminium sulfate, calcium hydrogen phosphate, zinc oxide, and so on.